Hello, guys. Today we're going to be discussing another beautiful lesson on the law of chemical combination. In our previous lesson, we discussed the great job done by a couple of scientists, such as the Russian scientist by the name Mikhail Lomonosov. He started a great job on the law of conservation of mass. Then, 33 years after, in the year 1789, the French scientist by the name Antoine Lavoisier propounded or put out a law that is known as the law of conservation of mass or matter. Then, 5 years after this law was put out, another French scientist by the name James Louis Proust started a great job on the law of definite proportion or constant composition. And the law states thus. Now, the law states that it states that all pure samples, I want you to note this, pure, very important, all pure samples of a given, all pure samples of a given chemical, all pure samples of a given chemical substance contains the same amount, of atoms, of elements, contains the same amount of atoms of elements combined in the same proportion, or ratio, by mass. Now, this very law, we are talking about the law of constant composition or definite proportion. Now, as being said earlier, was put out by the French scientist James Louis Proust at the age of 40 in the year 1794, just 5 years after Antoine Lavoisier's great job. Now, what does this law? What does this law? What does it talk about? What is this law all about? This law simply says that regardless of the method of production, used in bringing about the production of a given chemical substance, it does not change the constituent proportion of the very given compound. What does it mean? For example, let's say, e.g., you have aspirin. For example, aspirin, a given drug used for for curing and pains and the rest. Aspirin has a major chemical formula of C9H8O4. Now it's a carboxylic acid. And when you look at aspirin, now imagine a drug like aspirin. Imagine, as we have here, as you can see here, we have 9 atoms of carbon, 8 atoms of hydrogen, then 4 atoms of oxygen. So it means the carbon to hydrogen to oxygen ratio is ratio 9:8 to 4, and this must be maintained